Hello and welcome to today's class. We are going to look at last subtopic on matrices, and we are going to try to solve simultaneous linear equations using matrix method. So let's say that you have been given a linear equation ax plus by equals to p, and cx, all right, plus dy equals to q. All right, and you have been told to find the values of the unknowns, of the unknown x and y, of course, using the matrix method. All right, so what you want to do if you're going to solve this equation using matrix method, you want to put all the coefficients in a matrix form. All right, so you're going to have A, B, C, and D forming our matrix there. And then we will multiply this matrix of coefficient matrix with the variable matrix. So we're going to have the two unknowns, x and y, forming the variable matrix right there. And then we will have whatever is after the equal sign forming another matrix on its own, that is P and Q. All right, now this setup here is the general setup that we always and will always use when we are solving simultaneous equations. So this here is the coefficient matrix. All right, coefficient matrix. So this here basically is the matrix that entails the coefficients, and this here is the variable matrix. Okay, this here is the variable matrix. So having arranged it in this particular manner, it becomes easy to then go ahead and solve it. Of course, to solve it, then we will have to multiply the left and the right hand side by the inverse of our coefficient matrix. Okay, we're going to have to multiply the left and the right hand side by the inverse of our coefficient matrix. So basically, we are going to have that x y will be equal to, of course, when we multiply this by the when we multiply this matrix here by its inverse, we will have a situation. Of course, we're going to have a and d interchanging each other, so we're going to have dA here, and then we're going to negate c and b, so we're going to have negative c and negative b, and of course we're going to multiply the whole thing by the reciprocal of the determinant, and that is going to be 1 all over AD minus CB. So we will multiply the left hand side by that and the right hand side by the same. So with the right hand side, we also get to multiply it by the inverse. Of course, that will be 1 into AD minus CB into D negative C negative B A. Of course, I'm multiplying it by this inverse here. And so you will notice that when you multiply this by the inverse, you will get an identity matrix. Of course, that is going to be 1, 0, 0, 0 right there. And in here, we'll get the solutions to our problem. So the solution to our problem will be given by, of course, 1 all over AD minus CB, okay, into D negative C negative B and A right here, multiplying P and Q. So this here will give us the solutions, the unique solutions to X and Y. So then generally, that is the general formula, that's the general approach that we give to these problems that actually entail simultaneous equations using matrix method. Let us solve it using a real problem so that you're able to then relate to what I'm talking about. Right, so for our problem here, of course, this is the only problem we're going to tackle today. We have been told to solve for x and y using matrix method. So the first thing we want to do, we want to create our coefficient matrix. All right, so basically we're going to have a matrix open there. So we're going to have 3, and the coefficient of y here is 1. Good. And now looking at the second equation, we are having 4, and the coefficient of y there is 3. All right, then we're going to have our variable matrix. So we are having x as our first variable, and y as our second variable in that respect. And all of that is equal to 4 and 7. So I want you to look and see that these matrices are actually compatible. I can multiply these two because they are compatible. But that is not the aim of multiply. That is not what we're supposed to do next, basically. So the next thing we're supposed to do after we've arranged this matrix in this particular setup, we are going to multiply the left and the right hand side by the inverse of our coefficient matrix. Okay, so the inverse of our coefficient matrix. Of course, the inverse of our coefficient matrix will require that we interchange the elements in the main diagonal. So that's going to be 3 and 3. And negate the elements in the other diagonal. So it's going to be -4 here and -1. And then we are going to have to multiply the whole, we're going to have to multiply the whole matrix by the reciprocal of the determinant of this particular coefficient matrix. All right, so what is our determinant? Of course, our determinant will be gotten by the product of the elements in the main diagonal, that is 3 times 3, 9, minus 4 times 1, all right, minus 4 times 1. So it's 9 minus 4, all right? 9 minus 4 will give us 5. So it's going to be 1 all over 5 here. So this here is the inverse of this coefficient matrix, and we've multiplied it by the left-hand side already. So we are supposed to do the same for the right-hand side. So for the right-hand side, we are going to have the same. We are going to have 3, -4 here, -1, and 3 here. And then we will multiply all of it by a scalar of our determinant, that is 1 all over 5. All right, 1 all over 5, which was the reciprocal of our determinant. All right, now I don't have to go about it, but if you multiply this inverse of this matrix, if you multiply the coefficient matrix by its inverse, we expect to get an identity matrix. We already did that in the previous video. So we are going to assume that this here will give us an identity matrix, and so we won't waste time in doing it. So basically, we expect an identity matrix when we multiply these two, including the scalar, times the xy variable matrix, being equal to 1 all over 5 into. Now, we're going to multiply, just a minute. Sorry, so to ensure that these two are compatible, we are going to multiply these 3, -4, -1, and 3 by 4 and 7. All right, so I've basically rearranged it because this the inverse should be, in the left hand side, then followed by whatever we had there, 4 and 7. All right, so that we ensure that there's compatibility. Remember, this here has a matrix. This is a matrix of order 2 by 2, and this is a matrix of order 2 by 1. All right, so we have to arrange them in this particular manner to ensure that there is compatibility. All right, to ensure that there is compatibility. So when we are to multiply in this particular setup, these two are not compatible. Okay, these two are not compatible. This is of order 2 by 1. This is of order 2 by 2. When we multiply this by this in this particular arrangement, it won't be able to give us the answer. However, when we rearrange, then we are able to find compatibility. Hence, we can go ahead and multiply the matrix. All right. So we are going to multiply this particular matrix here. So when we multiply the identity by x and y, we will get x and y. All right. These two matrices, when we multiply them together, we'll get x and y. And that will be equal to 1 all over 5 into. Now, 3 times 4. All right. 3 times 4. That is 12. -1 times 7. -1 times 7. That is going to be -7. All right. That is it for that. And then for our second row, we're going to take -4 times 4. And that's going to be -16. Sorry, -16. -16, yes. So -4 times 4, that's going to be -16. All right, plus 7 times 3, which is going to be 21. So basically, we are going to get x, y being equal to 1 all over 5 into 7 minus 12 minus 7, sorry. 12 minus 7 will give us 5. 12 minus 7 will give us 5. And negative 16 plus 21. Negative 16 plus 21 will give us 5 as well. All right? So this therefore requires us to multiply the scalar by whatever we have here. So for us to find the value of x and y when we multiply by the scalar, we notice that our xy, let me just create some space here. Our xy will be equal to, when you multiply this matrix by the scalar, that is 1 over 5 out there, we're going to have 1 and 1. So our value for x equals to 1, and our y value is also equal to 1. And so that there is our solution for this particular problem. So it is as simple as that. You're basically supposed to arrange it in that particular setup, then multiply the left and the right hand side by the inverse of the coefficient matrix, and then everything else just simplifies itself out. Okay, thank you for that. Thank you for your time, and I'll see you in the next class. Have a wonderful day. If you have a question, post it in the comment section, and I'll get back to you.